right. Thank you so much for making the trek all the way back over here again. I'm sure everybody was here this morning. It's good to see everybody back in here. Thanks for coming to Sign, Sealed, and Delivered. Sign and verify all the things. My name is Jeremy Rickard. I am a principal software engineer at Microsoft Azure, and also a co-chair of SIG release in the Kubernetes project. Today we're going to talk a little bit about container supply chain security with a large focus on signing images and doing verification for that, and how we can use that to verify the authenticity of our resources. Some of what we're going to cover today are things that I've picked up in my day job. In my day job, I help build and publish a lot of CNCF projects for use inside of Azure and Microsoft as a whole. Also things from SIG release and other things I've seen and learned about in other projects. But let's start off taking a minute to reminisce about the early days, maybe the easier days of computing with containers. For me, I found containers probably around 2017-ish, and I was kind of drawn to it because I found that it was really easy for me to package up my application and get it to run in a really similar way to how it did on my desktop. You were basically a Docker push away from getting something up and running, and a lot of things were free in that time. You know, in 2017, I could push something to Docker Hub, and then I could deploy it to production, and it was just kind of free, and it worked, and it was really cool. It made demos at KubeCon or other conferences really, really easy, as long as the Wi-Fi was working, and just kind of gave you this kind of carefree experience. So with that in mind, and reminiscing, I thought that I would try to deploy an application as part of this talk. We're going to talk about supply chain security and how it applies to deploying an application. So I thought I would find something kind of old. Here we have the Emoji Vote app. I think it was published by Buoyant in 2017, so we're coming up on a long time on this thing. And yesterday, there was an election in my home of Colorado that was almost entirely pointless. So having this as a voting app seems like a really good idea. I found this thing on the internet. It's from 2017. It's probably going to be completely fine and all right? We're gonna deploy it. There will be no issues whatsoever. I should just be able to deploy this, and hopefully at the end, we'll get a cluster IP for this thing, and everybody can pull up their phone and try to vote. But actually, things aren't so carefree now. Who has had a rate limit from Docker? Yeah, almost the entire crowd. So Docker Hub was that ubiquitous registry, right? Everybody used it. It was free, and we just all kind of grew to depend on it. Open source projects published there. Teams used it. You may have had a paid account for it, but you were still using it because it was just so ubiquitous. But now, there are rate limits that are put in place, and for free accounts, they're pretty strict and pretty limiting. I ran into this getting ready for this application, or for this demo, because these images originally are in Docker Hub. But in production, you may end up getting hit with a rate limit when you're trying to do a scale operation or spin up a new application, and that's just kind of painful. You can also lose access to these things when registries go away. Who had to migrate to registry.case.io for their Kubernetes use? A few hands. That was pretty disruptive too. A lot of people had dependency on the GCR instance that we use upstream. When those go away, you lose control of that as well. Then there's the ever-present problem of vulnerabilities in containers. Who has spent some time in the last year remediating vulnerabilities in a container? Again, like almost all the hands. Super fun. If you have regulatory concerns, you're probably fighting this day by day by day. And if you're pulling all your images from a third-party registry, or maybe for your dependencies, you're still going to be stuck with that situation where you're going to be dependent, really, on that upstream project or that vendor to fix those things for you. If you're running in your own registry, there are some things that you can do, and we'll take a look at that. In this case, we're looking at one of the images from the Emoji voting app. It's got 394 high, 61 critical vulnerabilities. Probably shouldn't run this in production. If I did this at Microsoft, I'd get a lot of S360 alerts. And then a third category, and there are a lot more, but a third category is that sometimes maybe a registry's credentials get compromised, and somebody's able to push a compromised version of Kong that has some maybe nefarious things baked inside of it. If you're depending on these third-party registries and you're pulling things without the ability to really validate who's doing it, so in our voting example, was Buoyant who actually pushed that image? You can potentially get things like crypto miners or other bad things running in your production workloads. And this is also true of your deployment manifests and other resources that you're going to use to deploy your application. Somebody could make a change in, say, a Helm chart that you're deploying, and suddenly you've got some bad defaults changed, or there's a configuration change that now exposes a security vulnerability to you. So we've moved on from that carefree world to now we're all really aware of this. And I, at least as a person trying to deploy the voting app, am a little frustrated. It's not a happy experience in the container land. It's full of sharp edges. There's danger around every corner. It's kind of an angry experience. It's definitely not carefree. And it's probably going to cost me a lot of money and time to fix this and to keep it healthy over time. So what can we do? We can sit there and be frustrated and not know what to do. Or we can start to apply some well-known practices to our container secure supply chain and start to take control of that. And if we put those practices in place centrally for all of our teams, then we're going to get some shared efficiencies for that and be able to make everybody kind of fall into that golden path. And hopefully for new projects, we'll get them off on the right start. Some of these, again, are loosely defined or inspired by things that we're doing at Microsoft. Some of them come from other projects in the ecosystem. Some of them are from just blog posts and other things we've seen. And there are a ton of practices you can follow. The Tech Security has a white paper around software supply chain security that's really good to read. A lot of good ideas inside of that. And there's a few sessions throughout the week. If you go to Sketch, you'll be able to find some cool things around this topic. Right before this, there was something talking about applying some of these to AI models in registries. Kind of cool. So we talk about container supply chain security, but what we're really talking about now is supply chain security for our OCI artifacts. Because essentially anything can live in a registry now. Who has pushed something other than a container to a registry? Pretty decent size. That's a lot. The OCI spec was evolved over the last couple of years to provide guidance on how to store non-container images, non-container artifacts in registries. It's really cool because you get the same kind of distribution mechanism that you get for container images. You get the same kind of immutable references as you get to container images. And you can apply some of the same tooling to that. You also get side effects like everything's condensed into one place. I can take advantage of a central authentication or an authorization scheme for those things and deal with everything kind of in the same way. These could be things like Helm charts. They could be Flux configurations. They could be SBOMs. They could be vulnerability reports. Practically anything can get pushed to a registry. There's a number of tools that can do this if it's an OCI compatible registry. ORAS is one that we're going to take a look at today. So what are a couple of things we can do here? So first, we could mirror all of our images to an internal registry. All those external dependencies, we're going to put them into an internal registry. And then we're going to sign them so we know that we put them there and we intended for them to get there. And as part of that process, we could scan them, we could look for malware, do a lot of other things, potentially patch them as well with a project like COPA, and then make sure that those are available in our registry. Then, in our clusters, we can enforce that images only come from that registry to lock things down even more, to ensure that we're not going to have any problems from third-party stuff. Then we can start to verify our containers on deployment, and we can start to verify our deployment manifests on deployment. We're also going to stick our manifests and stuff in that registry as well. So what do we mean by verification? Well, by verification, I'm talking about the chain of custody for that. So going back to voting, the election in my town, it was yesterday. Colorado, where I'm from, has 100% mail voting. It's pretty cool. So you think there's probably going to be like, fraud or questions about the authenticity of ballots. Well, it starts with a signature, just like we want to think about for containers. Once you sign that, you're making a self-attestation that I produced this image, and I am delivering it to the registry or the Dropbox where I'm going to put it. Then, as somebody picks it up and moves it along the stage, you get additional signatures kind of co-signing that along the way. Then when it's finally time to validate, it goes through a manual and an automated process where your signature is compared to that of another certificate, something like your driver's license, your voting record, other things the state has on file. And when your signature does not match, it is rejected. There's a process for you to fix it, but it's not counted right away, right? It's rejected from admission into that voting system. So containers are the same thing. How do we verify containers? There's a number of tools that are in the ecosystem. There's an old version of Notary. We have a new thing called Notation. Cosign exists in the space. There's other things that are in the ecosystem. But they essentially work the same way, right? We are going to sign that we have produced this image, generate a signature object that goes along with that. That's going to sign some of the metadata for the container and produce another artifact that we can store in the registry alongside of it. It's discoverable in a known place, and then we can use tooling like Kyverno or gatekeeper to verify that that thing was signed how we expect it. So here we are. We're going to run an image here, test verify image, that it was signed by somebody else. Our policy is configured to reject that, and we can see there's an error message. So it was prevented from coming into the cluster. Well, we can do that for anything that is in a registry, right? So here we go. Use the ORAS tool. I pushed an image. It's an image to Docker Hub called Bleppernettes. If you ran this command right now, you would get a picture of my cat, who was the 120 Kubernetes release mascot. And then using something like notation, you can verify that signature. So notation verify, it'll verify against a trust policy, and I'll show you that in a little bit. Okay, so at a high level, what we want to do is take our images from Docker Hub or GCHR, put them into an internal registry. Then we want to make sure that Kubernetes only pulls from that registry. Then we want to publish our app config to the same registry. And then when we deploy that application, we want to verify the signature, verify the deployment, and hopefully everything is happy. There's a lot of stuff in commercial opportunities for this, a lot of products, a lot of open source things. But I was curious, could we do this and maybe patch them? Could we do all of this from just the CNCF ecosystem, from the landscape? And it turns out, yes, there are projects that cover all of these things across just the CNCF, and I'm going to use a stack of them now. We're going to do a demo. I'm going to switch over to that right after this. But the projects we're going to use, for a registry, we're going to use a project called Zot. Another option here might be Harbor. We're going to use Flux to do deployments because I know that I'm going to use notation as the signing piece because that's the one that's in the CNCF. And Flux has really great support for notation, and it's got support for OCI-based artifacts. I'm going to try to patch the image when I'm retagging it with COPA. I'm going to use ORAS as the registry client to move things around, and then I'm going to enforce things inside of the cluster using Kyverno. So all CNCF projects, all of these things we should be able to make play together. Okay, we're going to do a demo now. I have a QR code here. If anybody wants the repo, you can scan it, and I'll leave it up for a second, and then we'll jump over and start to take a look at a couple things. So I'm causing trouble for the AV people, so give me just a second. We're going to mirror. I think we're good to go. Okay, so I'm going to bounce over to a VS Code window, and I'm going to make this a little bit bigger. We're going to start by looking at what a trust policy is. So a trust policy is a thing for notation, and it's really going to say what trust store do I want to use, and this is where my certificates are going to get stored, and what identities from that trust store. I could do multiple identities here and really limit it down. In this case, it's going to be a certificate that I generated that's an Azure Key Vault for my domain, jeremyrickard.com, and all the stuff that goes along with that. I can also limit this down to certain scopes inside of the registry. So these could be individual registry or repos, like Cube Proxy, or I could wildcard it like this. Probably less secure to do this, but easier to see on the screen. Okay, so what we're going to do next is run a GitHub action. And I already started it here. And we are going to retag some images. I'm going to run it again while we are waiting. Oh, it's the wrong repo, that's why. Here we go. This is the right one. Sorry about that. Big screen again. Okay, we're going to run this and retag stuff. So what this is going to do, I'm going to run it and we can see it, is I have a list of all of the images that I'm going to use for this demo. And all of these images exist in Docker Hub or they exist in GCHR. So while that's running, what I did was some homework ahead of time, and I found all the images that we need to use for all the components we're going to deploy here, including Flux and including Kyverno. I made a little YAML file and wrote a really small Go program to spit out a GitHub matrix. But really what I'm going to do is use ORAS to copy everything. So I made a GitHub action. We'll take a look at that. And this GitHub action is going to run my little retag command that's going to spit out a matrix, right? So one of the cool things you can do in GitHub Actions is generate a matrix of all the things you want to run and run all these jobs kind of simultaneously. So I am going to start by running that, and then I'm going to install ORAS. So there's the GitHub action for installing ORAS. Pretty cool. I'm going to log into my Docker registry. There's a GitHub action for that. This was super easy because almost all of this, I just used GitHub Actions that existed already. Once I have everything set up, I'm going to use the ORAS command to run a copy. So get that out of the way. What we've got here is ORAS copy from the source to the destination, essentially. That's going to run for all of the images that are in there. And then I'm going to log into Azure, because my stuff is in Azure. I'm going to install Notary, and I'm going to use the AKV plugin for notation and run notation sign. So we can see we're going to run notation sign. We're going to tell it what to sign. We're going to sign registry / destination / matrix, the key IDs, and all that good stuff. Then I'm going to scan it, because I want to know if it has any vulnerabilities. So I'm going to use an action from from Aqua to run Trivy. Then I'm going to check and see if it has vulnerabilities. And if it does, I'm going to run Copa, which is another CNCF project that does container patching. Pretty cool. It'll take your container, it'll scan it, it'll take a result from Trivy, it'll generate a patch layer and pass that on for you. And then I'm going to just push it to the registry. So this should be running now. Oh, it's waiting for me to approve it, because I made this public. Okay. So we're going to let that run for a second, and I will come back to it once it's done. So once these images are all in the registry, the next thing we're going to need to do is have a Kubernetes cluster, right? So I've got one already. Didn't want to wait for that. We've got a Kubernetes cluster that is an AKS cluster, because I wanted to make it public for everybody. So we've got, let's see, kubectl get nodes. Okay, 2 node pools there. We also have our Zot server already running, and that's right here. Okay, we can see that it's running. It's also available. Actually, it's getting stuff pushed to it already. If we go to Zot here in the browser, it doesn't have images yet, but this GitHub action should be running for us. And it's copying things with notation right now, or with ORAS right now. And you can see that it's going to set up the notation CLI. It's going to sign everything. It's going to generate a Trivy report and do all the things that it needs to do. Okay, so if we refresh Zot again, hopefully we've got images, live demo. Yes. So we have image reflector controller, Kyverno, a few other things. And we can see that right now they are not signed, because that GitHub action is still running to do the signatures. Okay, so while this is all going, we'll come back to it. A couple other things that are in this repo that are interesting to us. First, here are a bunch of manifests that we're going to use for our application. It's going to take some work to use mirrored images, right? We're not going to be able to just take an off-the-shelf Helm chart and just run it as is. If we have YAML files, we might need to do something to them. So we're going to use customize to do almost all of this. So we've got definitions for all of these things here. We've got our voting app. We've got Flux. We've got some Flux repos that we'll talk about, Kyverno, and then some policies we're going to put in place. While that's all running, the first thing we can do is install Flux, right? So let's do that. Hopefully the Flux images are all across. So it looks like they are not all across yet, but we'll run it anyway. Okay, so we're going to make sure we're in this project. Make sure I spell correctly. All right, so again, here's the directory. Manifest is where everything is. So let's do a kubectl apply. We're going to use customize, so -k, manifests, Flux. That's the first thing we'll do for this cluster. So it's going to create everything. And if it hasn't mirrored all the images, we should be able to see some errors, and that'll be cool. Okay, let's get the pods. Okay, so all the stuff is running. It looks like our Flux stuff is coming up right now, so that's cool. Next, how about we install Kyverno? We'll get that out of the way too. Okay, so we're going to use Helm for that, just because they have a Helm chart already, and I want to show you how to customize with that. So we're going to install Helm with Helm. Okay, and you can see here that for this, I basically had to overwrite all of the images in the chart. So it's not the easiest thing to do, but it makes you kind of aware of what you're doing. Okay, so we're going to run Helm install Kyverno, set the namespace, set the registry, all those good things. It's going to run. While we're waiting, let's check on our GitHub action. Looks like they're all done. So for each one of these things now, we saw that we ran that retag operation, we signed everything, we scanned it with Trivy to see if there were any issues. And if we go to our registry now and refresh it, now we see that it's actually signed. That's pretty cool. So we could pull these images, you could pull them from zot.jeremyrickard.com, and you'd see that there are notary signatures associated with each one of those things. Okay, so now we've got Flux installed and we've got Kyverno installed. Let's make sure everything's looking good. Okay, all of our pods are now running. Okay, so we've got Flux installed, we've got Kyverno installed. What we really need to do now is handle the policies, right? So let's take a look at what we've got under policies. So we've got 2 Kyverno policies. We could have done this first and then enforced it for Flux as well, but we have 2 policies we want to install. The first is that we want to restrict images. This is a really basic thing. You could use this anywhere. And all it's really going to do is ensure that everything is coming from zot.jeremyrickard.com, and you will get an error if you don't. The second one, though, is the more interesting one for this use case, because we are going to use the built-in verifier for notation. So here we go. Again, it's a cluster policy for Kyverno. We're going to verify signature notary on resources of type pod, right? That's where the containers will be. Any image reference, we want to be signed with this certificate. This public, so behind the scenes, this will generate a trust policy for us and do all the good stuff. So we're going to run that now and apply it. kubectl apply -f manifest policies. Let's put them both in place. Okay, cool. So now we've got both of those things ready to go. The last step that we really have here is to use Flux to install our application, right? We have a pipeline for that too. So let's go take a look at that GitHub action. So again, we said we wanted everything to be inside of the registry, right? So we're going to do the publish Flux config now. Let's take a look at what that pipeline looks like. Or sorry, that GitHub action looks like. It's pretty simple. It is going to log into the registry because it needs to push. It's going to install the Flux CLI because it needs Flux. It's going to install notation because we're going to sign it. And then it's going to call Flux push artifact. And you can see the arguments that are going to get passed to it. So Flux push artifact, all those good things. And then we're going to sign it. And this is exactly the same configuration with just a different target artifact. So is it running? Is it running? We have to approve it, right? Yep. So let's approve that. View deployments. Okay, so this will put it into the container registry, or the OCI registry. It's not actually deploying it to Flux. What we're going to need to do to Flux is give it another configuration that says to install that resource. If you've ever used Flux, this is exactly the same way as specifying that you're going to use a GitHub repository instead of the OCI registry. The big difference is that it's going to pull it from that source instead. And again, that's a cool kind of side benefit because you no longer have 2 paths that you have to control access to, right? Maybe you want to lock your clusters down. Putting them all in one registry might be a good way to do that. So let's take a look at what happened here. We pushed this Flux configuration. It's called KubeCon manifests. So if we go to Zot, I wonder if we can find that. Yeah, KubeCon manifest emoji voting. And we can see that it's signed, right? That's pretty cool. You would see this with cosign or the other things as well. So we've got that installed now. So our last real thing to do is to kubectl apply -k manifests emoji voting. Oh, actually, that's the wrong thing to do. Let's delete that. Sorry. Okay, so it's deleting that. So what we really need to do is we need to use Flux to do that. So in manifests, let's take a look and see what we've got. We have Flux repos, right? So let's go to Flux repos. And we've got 2 things in here. We have emoji vote, and we've got something called notation config. But let's ignore that for a second, and let's just apply this one. Okay. So we are going to create 2 Flux configurations, right? So we've got a OCI repository source and a customization for Flux. The 2 resources are going to help us define our application. Let's take a look at them in VS Code because it's a little easier to read. And here we've got this. So we can see in this we've defined an OCI repository type, right? The spec for this is going to reference that object or that resource that we pushed to the OCI registry, which is going to be our collection of manifests. And then we define a customization that uses that as a source. The interesting thing here, though, is that there's a verifier. So we're going to verify that thing with notation, with the notation config secret. Guess what I didn't create in the cluster? That secret. So if we get pods, I don't see anything running for our voting app. That's kind of a bummer. I wonder why. Well, let's take a look at the source controller for Flux and see if there's any logs. It failed to verify the signature using the provider notation, mostly because the secret wasn't there, but that's the easiest thing to do for the demo. So if I create that secret, we are going to now have that secret present. So as reconciliation starts to happen here, there it goes. It's applying that thing. It was able to verify the signature because we said that it had to be verifiable, and now it is ready to go. Okay, so moment of truth. Oh, I see all the emoji voting apps. Cool. And there is our service. Looks like the IP address is 172.206.153.116. Let's see if we can pull that up in the browser. All right, it's there. Let's view the leaderboard. Oh, I don't think it's working all the way. That's a bummer, but it's deployed. It's running. So we've got our cool app from 2017 now deployed with some kind of modern supply chain security best practices. That's kind of fun. Let's look one more time just to kind of refresh our mind. So we were able to push an OCI packaged set of manifests to a repo or registry that's running as it's a CNCF project called Zot. We were able to verify that thing using a CNCF project called Notation. We're doing all this deployment with a tool called Flux, which is a CNCF project. We were able to restrict images here from a CNCF project called Kyverno. And if we go to look at those cluster policies, I bet we can see what it's telling us. Yep. Let's see. Let's get one and see what it says. Okay, so there's a certificate that's included, just like we saw in the log. Looks like a normal document, a normal object. Let's see if we can describe it. If I could type kubectl, and that is called check image notary. There we go. So there's some policy violations. Oh, I put this in warn mode because I didn't actually want to copy all of the cluster images because some of them are coming from AKS. But we can see there are some things there, like Kubernetes metric server that was built by my team. It's not signed with notation. Oh, it's not signed with this, this trusted signature. It does have a signature. It just did not get signed by the signature we're looking for. Cool thing with this is that your trust policies allow you to define exactly the level of trust. So I could go back and I could add this public cert to my trust policy and I could allow these registries and clean this all up. Maybe allow for things to come from another registry as well. But don't really need to do that. All right, well, that is the end. So let me bounce back to PowerPoint here. I'll give you the feedback thing, so you can take that. I would love to have any feedback that you might have. And I will hang out to the side if anybody wants to chat about anything after this. Stop extending. Okay, back to the... Oh, a couple of things real quick. These are 3 talks that I thought were really interesting. 2 are tomorrow and 1 is on Friday. Go check out the project booths as well. I think there's some really interesting stuff there. And there's the QR code for feedback. Thanks again for coming all the way over here. It was really cool to see so many people in here. Thanks.